Question 12a, given a function here, we are going to use first derivative test to determine the local extremum for this function. So before we get to the local extremum, we have to find out the stationary point from this function. So for the fx equals to x power 4 minus 2x squared plus 1, we're going to differentiate. We're going to find its first derivative. So power move to the front, power minus 1, power move to front, power minus 1. So this is our first derivative result. Then, in order to find stationary point, I have to let f prime x equals to 0. Means we have to let this cubic equals to 0. And we simplify. So this equation we can divide by 4 because it has a common factor of 4. And we try to factorize. So our critical value of x is 0. Another critical value is equal to 1. So x, when we move the square to the right hand side, it will be positive negative square root 1. So x will be equal to 1 and negative 1. So we have 3 critical value here. Means we can form out our 3 stationary point here. So in order to find its y coordinate, when x equals to 0, our y coordinate will going to substitute into the function. So when x equals to 0, y will be finding, substitute this 0 into the function. So 0, 0 equals to 1. So y coordinate equals to 1. So our first stationary point. So when x equals to 1, the y coordinate we substitute into our function here, it will be 1 minus 2, then plus 1. So it's equals to 0. And the third coordinate x equals to negative 1, substitute into the function negative 1, as negative 1 power of 4 equals to 1, power of 2 also equals to 1, 1 minus 2, then plus 1, it is equals to 0. So we have 3 stationary points here. So from these 3 stationary points here, we're going to do our first derivative test, as the question required here is first derivative test. So we will use table. We'll use table to find out our local maximum, to find out whether this point is maximum or minimum. So we have to verify it. So as we can see, our x value has 0, 1, negative 0. So we have 3 critical value. So in order to find out our interval, so you will have 4 interval. From the smallest interval, it will be x less than negative 1. And then negative 1 until 0. And then 0 until positive 1. After that, x more than 1. So this is our interval we have to go into test for. So the test value we can use here, it will be randomly. As long as it is less than negative 1, we choose negative 2. Here we will choose negative 0.5. Here we choose positive 5. Here we choose 2. So we are going to see for this interval whether the gradient of the tangent is increasing or decreasing. Because when we're talking about first derivative test, the idea of first derivative test is to see the tangent of the curve, gradient of the tangent of the curve. So whether it is increasing or decreasing. So we are going to substitute this value into our first derivative test and then to come out the conclusion. So substitute this value into our first derivative test. So substitute negative 2 for this first derivative answer, we will get this negative. And then the next interval, as we substitute negative 0.5 into this, we'll get positive. So continue substitute this value into the f prime x here, we get negative. So you can use this by pressing your calculator. So as we can see, our result here is negative, positive, negative, positive. Means that negative, the gradient of the tangent will going down, will be decreasing. Positive, the gradient of the tangent will be going up. So from here we can see the point of negative 1. So this is the point, this is the point of negative 1, 0. This is the point of 0, 1. This is the point of 1, 0. So this is the interval before before this point. This is the interval from the left hand side, interval from the right hand side. This is the interval for the left hand side interval and right hand side. So we can see for this point you're going decreasing then increasing. So means that this point is minimum point. For this point, it is increasing first, then after this point, you're going to decreasing. So this is maximum. So meanwhile, for this point, the gradient is going to decreasing, then going to increase again. So from here, we can conclude out, say that negative 1, 0, and 1, 0, there are minimum point. Meanwhile, 0, 1 is maximum point. So this is how we use our first derivative to find out our local extremum. Then we continue for question B. A ladder of 5 meters long is landing against a vertical wall. So the situation now is, this is our wall, and then our ladder is going to landing here. So this ladder is 5 meters long. As it's landing to the vertical wall, it is sliding down the wall. The foot of the ladder is 3 meters away, so it is sliding down, so it's going far away. So 3 meters away from the wall, and the top of the ladder is slide down. So here is going to slide down 0.5 at the rate of 0.5 at the rate of 0.5 meter per second. So the question asks us, at what rate is the foot of the ladder moving away? So when moving away from this wall when it is 3 meters. So we can see. For first, we are going to identify our shape. We can see this is a triangle shape. Then we're going to define our variable. So I will define the y as vertical distance, x horizontal distance. So x is a horizontal distance, and then y is the vertical distance from the wall. And then given that it is sliding down the rate, so this ladder is sliding down, so this rate of change is dy dt, because the length of the y is decreasing. When you can see this ladder sliding down, the length of y will be decreasing, so this rate of change will be in the properties of negative, so negative meter per second. So they are going to ask what's the rate of foot. So what's the rate of this horizontal distance? They ask us find dx dt. When the ladder is 3 meters away, so this ladder is 3 meters away, means our x is equals to 3. So after we read through the questions, we identify the shape, we get to the information, so we have to find out. So what's the formula using here? As we can see, our shape here is a triangle with height and the base of the triangle also given. Means this from this diagram we can use our Pythagoras theorem. So from here we can build up a formula, Pythagoras theorem, where x squared plus y squared will be equals to 5 squared. So our formula will be x squared plus y squared equals to 25. So in order to find the dt, we are going to differentiate this equation implicitly. We will differentiate this variable with respect to t. So when we differentiate x with respect to t, it will become 2x dx dt, because it is not our unknown t. Meanwhile, for y also, we're going to differentiate, so it will become 2y dy dt. So from this differential equation, we can see dy dt already given, and then y not yet. Value of x is already given, so we have to find out our value of y. Then only we can find what is our dx dt. So since we already have our value of x here, we can use our formula where x squared plus y squared will equals to 25. So 3 squared plus y squared will equals to 25. So y squared will be equals to 25 minus 9. So y will be equals to 4. So negative we didn't put because y is defined as the horizontal distance. Distance will not have negative. So lastly, our information is complete, then we can substitute into our differential equation here, where x is 3, we're going to find out our dx dt, y is 4, and dy dt also given, negative 0.5 equals to 25. So we move this to the right hand side. So just now we have a mistake here. When we differentiate constant, it should be getting 0. So I repeat, for this, differentiate with respect to t will be 2x dx dt. Differentiate y with respect to t will be 2y dy dt. Differentiate constant will be equal to 0. So move this to the right hand side, will equals to 4. So dx dt will equals to 4 over 6, which is 2 over 3. So this is a cm unit. Length is meter, time is second. So meter per second.